Hi, right, so sorry about that. I got interrupted by the video being just too long because I talk too much. Right, so, yeah, we were talking about partial polarization of light. And so this is the action of light hitting a surface, and obviously some of that capacity to vibrate up and down is limited upon reflection. So that some of that reflected light will be polarized ever so slightly more in a different plane. That can be detected. So, well, it can be filtered out because of that polarization. We can filter that out. So if we only let through the vertically polarized light, then light that we're looking at from the sun we can see, but things that are reflecting off of surfaces, that's going to have most of that glare is going to be in the horizontal plane. So we want to filter that glare out. Now the sunglasses can do that by being polarizers. Can you see how they're polarized? Reduce thing. Now I've also got some genuine polarizers over here, which I say genuine, they're actually more genuine, they're Polaroid brand. These are just sort of some fake thing. Here's a polarizer. I rotate it, you can see there's no change. Right, there may be some change. No change. Right. Now if I get two polarizers, put them back to that, and then rotate them, you can see it becomes black. Rotate it, clear, black, clear, black. So that's because they're both in the, let's say, vertical orientation there. That's in horizontal, that's in vertical. They don't let anything through. Cool. Cool, isn't it? Right. So Malice's law is how much of that intensity of light actually gets through as a function of the angle as we turn it. So all, none, half, who knows? Well, Malice knew, and it was to follow this rule, that the transmitted intensity is equal to the initial intensity times cos squared theta. Now that means cos theta squared, not cos of theta squared. So cos theta squared, not cos of theta squared. I think you know what that means. Right, there's some homework questions attached. Do them. Bye.